Hello, this is Mike Kent, Professor of Computer Information Technology at San Jacinto College on the Central Campus. Today I am recording a lecture for my ITSE 1329 class, Chapter 7, talking about file handling. All right, let's jump in. So, first we're going to talk a little bit about what is a file and how data is organized on a computer. I think everybody knows that. Then we're going to talk about performing file operations, what a control break is, what merging files would be, master and transaction files, and then random access files. So that's the major things we're going to look at. So what's a computer file? It's something that's stored on the hard drive. It's not in the random access memory of the computer. So it's permanent storage. If you shut the computer down, the values stored on the hard drive do not go dead. It's permanent. So the next thing we need to differentiate is text files, which are human readable. You can open them with a text editor or a word processor and look at them, versus binary files where everything is stored in the zeros and ones format that the CPU would understand. So these are not human readable. You'd have to read a binary file via a program. So what we're going to be concentrating and doing our assignments with would be text files. So a file name, we know what a file name is. The thing you may not realize is file names have an extension. Like a Microsoft Word document has an extension of docx. By default, Windows hides these extensions from you, but we're going to be looking at files that are like .dat or .txt. If it's .txt, it's a notepad file. It's just the simplest text file you can have. So, is everybody familiar, I hope, with different types of storage? Byte is one keystroke, kilobyte is 1,000 bytes, a megabyte is a million, a gigabyte is a billion, and a terabyte is a trillion. I don't think I need to elaborate on that any more than has already been said. Files on a computer have other attributes. They have a date and time. They have a size, how many bytes are stored in them. It has a location on the hard drive, like in this example right here, it's this PC, disk drive C, and then there's a folder called sample files, and these are the three files that are in sample files. Here's some other organizations, and if I wanted to access the file called payroll.data.dat, C++ programs, or programs in general, are not psychic. They cannot figure out where the file is. We have to tell it the exact location of the file. So in this case, it's C:\logic sample files payroll.data.dat. Now on Windows, you might have this C:\users username bubba.smith /desktop, that's the desktop you see when you have your computer open, /costs. So there would be a file called cost.txt on the desktop, and if I wanted to open that file from my program, I would have to give it this path right here, and yes, I do have to use backslashes. So a file is going to consist of characters. The characters are going to be grouped together into a field, in a series of fields like first name, last name, employee number, pay rate, number of dependents. Those would all be fields. They're going to be organized into a record, which is one value for each field for all the users. I mean, for all the record. Bleh. Let me say this again. A record is going to have a series of fields like first name, last name, employee ID, number of dependents. There'll be one value for each field in that record. So one record represents all the information on that one person, and then the file is going to be a collection of records. Now in database terminology, a table is a collection of records, and then a database is one or more tables. So if we're opening a data file, then the data file is going to be equivalent to just one table in a database. So we can see that breakdown here in figure 7-1 We can see an entire record. The record is broken into first name, last name, pay rate, year, are they a smoker, are they single, uh, what state do they live in, et cetera, et cetera. I'm not sure what all these fields are without a description up here at the top. And then the field for first name is a series of characters, and then one character out of that field is just one byte. Okay, so I think we're pretty familiar with this. How do we open and process data files? Well, the first thing we have to do is we have to declare a file identifier, a file handle. We have to tell C++ this object is going to be used to open a file. And you'll see that in C++. I'll give you an example of that later. Now, once we have that object, it's not pointing at anything. So then we have to open the file and point it at employee data.dat. And then we're going to read data from the file. Input name, input address, input pay rate, etc., etc., until we get to the end of file. So files, we have to mark the end of one field and the beginning of another field. Sometimes that's done with a comma or a tab character. In C++, it's easiest to just use the enter key. So one field per line, one value per line. And that's what you're going to see in the example that I've worked up that I want to show you in a while. So in this example, we have a data file that is comma separated. We have the name field, a comma, the address field, a comma, and the pay rate. Okay, and then this record would continue, and we can see the next record. Okay, that's one record. Here's the next record. So each line is one record. So that's comma separated data, and that turns out that's a very easy way to import data into Microsoft Excel. It reads that very easily, and many programs read comma separated data very easily. So this is delimited data. The comma means it's the end of one field and the beginning of the next, so you can never have a comma in the data because it means go on to the next field. And you can see how that data might be stored on a magnetic hard drive. So a sequential file, and that's the type of files we're working with, is like a stream of bytes you're reading into the program. So you got to read the first line of the file before you can read the second line. You got to read the second line before you can read the third line, and so on and so on and so on. One of the things we do with files is we read them into memory and we sort them, or we save the data in ascending order, so A to Z, or it might be descending order, Z to A, or it might be from who makes the most money per year to who makes the least money per year. So it can be sorted ascending or descending. Writing data to the file is basically the same as writing to the console. Instead of doing a CIN, you do a COUT, except instead of opening a file for input, you're opening a file for output. You're creating an object that's an output file, and every time you write to the file, it gets stored in the file. And when you close the file, then you have that completed data file, which if it's a text file, you can just open it with a text editor, like Notepad or WordPad or Microsoft Word. So the default input device for a C+ program is the keyboard. The default output device is the monitor. And you don't have to open or close those. Those open automatically when you run your. So actually, the way C++ handles text files is as if the data is coming from the console, from CN. You're just going to open up a file handle and point it at a file on the hard drive and open it, and then you're just going to read from it line by line, exactly as if you're doing CN, and I'll show you that example in a while. Another operation we might do is make a copy of a file. We read the values in from one file and we write them out to another file. So a lot of times you want to keep the original file unchanged while you're doing some processing until you know that the child file is good. So you have a parent child, and then the new file is called the child file. And once you're sure that the child file is good, then you can make it the parent file. You can make it the actual production file, and then keep a backup, of course, before you do this. So programs that perform file operations, the first thing we have to do, if you look at this diagram in our housekeeping, is declare an input file object and an output file object, and then we have to open the file. So if you look at housekeeping, our input file, employee data, is called employee data.dat, and then we're going to open our update data file, update data.dat. From in the real world, you'd have to say what folder this is on the hard drive. And then remember how we do a loop. We want to do our first input, or we want to prime our loop by doing our first input before we go into the loop. So what are they doing? They're inputting from the input file. From employee data, they're inputting the name, address, and pay rate. Okay, so now they're ready to go. Now, in the loop, we're going to be checking for end of file. If we hit end of file, we're going to get out of the loop. So they're saying not EOF. So if the answer to that is yes, then we're going to do our detail loop, which is to process that record we just read in. So what do we do in detail loop? We add the pay rate, we add the raise to their pay rate, then we're going to output their name, address, and pay rate to the output file, which is update data.dat, and then we're going to do our next input at the bottom of the loop, which is immediately going to go back up and check for end of file. So remember that sequence. We prime the pump, we do our first input before we go into the while loop, then we do our processing, and the last thing we do in the loop is do our input for the next time around, because if there's no data here, that will trigger end of file. Now, the author said not EOF, keep going. I would prefer to say um, while EOF equals false, while end of file is false, keep going. That's just a little bit more clear. Now, after we get out of the loop, after we've exited the loop, what do we got to do to finish up? We've got to close our files, because what a modern program does on a computer is it stores up a buffer of data that's the size of one sector on the hard drive. So for like Microsoft Windows NTFS, the default sector size is 4096 bytes. So when you're writing to a file, you're actually writing to a buffer in RAM, and when you get 4096 bytes, it writes it to the hard drive. And when you get the next 4096 bytes, it writes it to the hard drive. When you close the file, if you have a partial sector, say you only have 200 bytes out of the 4096, it will go ahead and write a sector of only 200 bytes, and the rest of the sector is unused, and close the file out. If your program crashes without closing the file, there's a possibility that the file will get corrupted because it has not written the end of the data, that last part of the data, to the data file. So this is the basic operation. Once again, we do our first input before we go into our processing loop. And then we already have the data we need. We process it, we write it to the output file, and then we read our next record at the bottom of the loop, and we rinse and repeat. We keep doing that. So here's the pseudocode for it. So we've declared our input file and output file. In housekeeping, what are we going to do? We're going to go down here, we're going to open our two files, and we're going to input the first record. So while not end of file, detail loop. Now what does detail loop do? It processes the person's raise, pay rate plus raise becomes the new pay rate, and then we output to the child file name, address, and the new pay rate. And then the last thing we do in detail loop is input the next record, the next employee. And then so as soon as it finishes with detail loop, it's going to hit end while, go back up and check for end of file. If end of file is true, it's going to drop out of the loop and go to finish. So that's why we read at the bottom of the loop, because if we read at the top of the loop, then we might be trying to process garbage. We would have a bug in our program. So this is always the way you're going to do it. You're going to do your first input before you go into the loop, and then at the bottom of the loop, you are going to do your next input. Now I can show you this. I've written a little C++ program, and I'm using an online C++ compiler. And let me pause this for a second and switch windows. All right, so I've switched to www.onlinegdb.com. This is an online C++ compiler, and let's look at the code. So we got to have some includes up here for C++. We want file stream and IO stream, and we need string because we're going to be handling strings. So, and of course using namespace standard, all this is regular. And then we have int main, that's just our main function. So what are the variables in this example? I've got float number, and I'm going to be reading numbers from a file. Float total, because that's what I'm going to be doing in the program. I'm going to be totaling these numbers up, so I want my total to start at 0. And then I have my file stream, my input file stream called fn, as in cn. Now the data file I'm going to be reading, if I come over here to numbers, I'm going to be reading in 42, 58, 100, 200, 300, etc., and I've got 12 lines of data. So after it processes all 12, it's going to exit out of the loop. So I'm going to open the file, filein.open. What file do I want to open? I want to open numbers.txt. You see, I've got numbers.txt right here, and unfortunately, it's putting that F8 in front of us. But that is numbers.txt. Then what? Before I go into the loop, I read my first number. So this is just like reading from the console, except instead of saying cin, I'm saying file in. You see, I called it fin, file in into number. When I do this line of code, that's going to read the 42. Okay. Now, are we at the end of file? No, we've just read the first line. We haven't read the whole file, so this is going to be false. In C++, that's not. So while not false into file, keep processing. Go into the loop. Then what's it going to do? See out. Here's the number I just read from the file. Then I'm going to add the number to the total, making it the new total. And then at the bottom of the loop, what am I going to do? I'm going to read the next number. So before you get in the loop, you do your first input, and at the bottom of the loop, you do your next input. So when this tries to read a number and there is no number, end of file will become true, not true is false. That will get me out of the loop. So what do I do when I get out of the loop? I close my file, and then I'm going to print out my total. So let me drag this up right here and let me run the program. It's going to compile it and run it. So if we look at the output, my messages in the loop is number read, 42, 58, 100, etc., etc., etc. Kept reading it, read the 10, and then what? My total was 111. I mean 1,111. So I picked my data on purpose so it would do that. It would print out, add up to 1,111. So take a look at this right here. This is our main processing loop. Do your first input to prime the loop while not file handle. That my file handle is called, my input file stream is called fin. While I'm not at end of file of that file stream, here it might be a little bit more readable if I do that. No, hang on. If I do that, there we go. While I'm not at end of file of file in, keep going. So what am we going to do in the loop? We're going to do our output, we're going to add it to our total, and we're going to read our next number and keep going. Okay, and then it prints everything out. Prints out the total at the end after I've closed the file. So that is an example of a file processing loop actually in C++. So this compiler right here, you can save your work on it, but you have to either you have to use your Google account, your Facebook account, or create a GitHub account. Otherwise, if you want to save your work, you just Control C, you select all and copy and then save it into a notepad file and then save that on your hard drive or a WordPad file or whatever. I added my data file by just saying new file right here. But this is a nice little resource if you want to try out some C++ code. It's onlinegdb.com. That's all you have to, that's all you need. See if I typed it right. So when you come into it, it just has a little hello world program and you can replace it with your program. So let me pause this, jump back into PowerPoint and continue talking about the chapter. So of course this is just pseudocode, not full C++ code, but I just showed you some C++. Understanding control break logic. So control break logic is we might have a data file that has a series of people from one department, and then it's got a series of people from the next department. So the file is sorted by department. Once we've read all the records of that department, we want to print out a subtotal for that department and then go on to the next department. And then at the very end of the program, once the file has hit into file, then we want to print out a grand total. So a control break is where you're sorting on like department or employee type or state or city or day of the week. And when you go to the next day of the week, that triggers a control break and you do a little special report before you go on and continue your processing. So in this example, we're doing a control break by state. Now the data file has to be sorted in alphabetical order by state. So we processed 3 records for Alabama, and then when we read the record for Alaska, that triggered a control break and we outputted count for Alabama 3, and then we continued processing normally. So as long as we're on Alaska, we're fine, and then as soon as we read Arizona, before we output this line right here that says Edwards, Phoenix, Arizona, we print out count for Alaska 5, and then we go on to Arizona. So that's a control break. Now, I'm not going to make you write any code on control breaks, but you need to know what a control break is. So here's some of the book examples. Employees are listed in order by department. Books that were sold in the bookstore by category. Date of sale, so we can get the subtotals for how much we sold each day of the month. And what I've talked about here is a single level control break. So what we do to make this happen is we have a variable that holds the current state. And every time we read a record, we compare the current state to the record we just read. And if it's different, if the record we just read has a different state from what we stored in current state, that triggers our control break. So if we look at this, it's probably going to be easier to read in the pseudocode. So this page of the code right here just has our variables, our input file, and our reports and our titles that we're going to print out. Then that's our start, that's our housekeeping. Then if you look right here, we're going to do get ready, and get ready is going to open our files and read the first record. Remember, we're going to do our first input before we go into our loop. Now, where the magic is going to happen is in produce report. So if I look at produce report, and I'm going to look at it in the pseudocode, if the state is not equal to the old state, what are we going to do? We're going to trigger a control break. So what's control break going to do? It's going to print out the count for this state, set the count to 0 for the next state, and then the old state becomes the current state. Now, when we did our first input, before we got into the loop, we had to set our old state to the first state we read. This is part of our processing to get going. So control break prints out the subtotal, sets our count back to 0, and changes to the next state. So after we get past our control break right here, what do? We're going to output name, city, and state. We're going to add 1 to count, and then at the bottom of the loop, we're going to input the next record. And then it's going to go back to check for end of file. So control break does what? It prints out the count for the current state, sets the count back to 0, and sets old state to the new state. So we've just switched from Alabama to Alaska. So finishing up does what? We're going to print out our grand total for the last state, and we're going to close our input file, and we're done. That's the end of the program. Merging sequential files. That's another thing you may want to do. You may have 2 data files with the same fields that are sorted in the same order, and you want to update the data in the main file from the transaction file. So basically what you have to do here is you have to keep processing until you hit end of file of both files. You're going to have 3 files open, 2 input files and 1 output file. And you're going to read records from the first file and the second file. You're going to read a record from both, see which one comes first alphabetically, write it out to the file, and keep reading records until it's time to write from the other file. So for this to happen, the data files have to be laid out the same way, and they have to be sorted in the same order. So, for instance, here's our first file, East Coast file, West Coast file, Abel, Brown, all these people, and their balances. And we want to create one file where we print out Abel, not print out, output Abel and 100 to the merged file. That's my output file. And then alphabetically, Brown comes next. So then we're going to write Brown. And then if we read Daughtery, excuse me, I didn't say that right. It comes after Chin, so we have to output Chin next. But you see we've merged the files into alphabetical order. So the mainline logic is similar to other file processing, except you're handling 2 files. And only when you hit end of file of both files are you done. So we define a Boolean flag to set to true when both files have reached end of file. So you're going to define 2 input files. You're going to read one record from each file. So that's what they're doing on the start. What are they doing here? They've declared 2 input files and 1 output file, and they've got their other variables they need. And then our main processing is going to be while both are not at end of file, we're going to merge records. Okay, so this loop is just going to keep going, merging records until both of these files are at end of file, in which case we're going to set this flag to true. So merge records is where this detail is happening. So what do we got to do to get ready? We have to open our files, our 2 input files and our output file. We have to read a record from the East file. We have to read a record from the West file. And it could be, that's it, we're done. There could have been no records in either file, so we need to check for end. Now, what check for end does is if East is at the end name and West is at the end name, we're going to set our flag to yes. Or in C++, you'd probably have a Boolean and set it to true. So we're going to set it to yes. So that's all check in does, is check to see if both files are closed. So when we read from East, we're going to input 1 record, and if we're at end of file, we're going to set it the East name to end name, and the same thing in West. Okay, and here we can see the pseudocode. So this is if East name equals East end name, then we're going to do our second if statement. If West name is end name, then we're going to set we're at the end flag. Okay, so when we read East, if we're at end of file, we'll set the end name. If we read West, the same thing, we'll set West name to end name. So get ready is just opening everything up. So merge records. All merge records does is if the East name is less than the West name, if that's true, then we're going to output the East name in the East record to the output file. If this is false, we're going to output the West name, okay? So that's going to decide which record needs to be written out. And here's the pseudocode. If East name is less than West name, output East name, East balance to merged file. Else, output West name, West balance to merged file. So that's going to decide which of the two records has to be written to the file next. Now, after we've written a record out, if we write a West record out to the merged file, then we have to read from West and go back up and try again. If we write an East record out to the output file, we have to read from East. So we keep doing this and keep comparing, deciding which record to write, either a West from the West file or the East file. But when we write a West file record to the merged file, we have to read the next West file record, and so on until we get to the end of both files. So you see, after we've outputted the record and read the next record, then we're going to check to see if we got to the end, if the flag has been set that we're at the end of file of both files. If that's the case, we're going to close all three files and we're done. So master and transaction file processing, you have a master file that has the complete and permanent data. The transaction file has the transactions for the day or the transactions for the week, and we need to update the master file with this transaction data. That's another type of processing we look to do. So a library has a master file of all the patrons and what books they've checked out during the week. We could add that to the master file. College maintains a master file of all students and the transaction for each course registration, so we have to update what classes they're registered for. Telephone company will have a master file of every telephone number, and we want to add what phone calls each telephone number is made for billing purposes, for long distance purposes, for minutes. So the updating approach is to change the information in the master file. You're going to write the output to a new master file, and once you're happy with that, it becomes the new master file. You begin with both files sorted in the same order on the same field, so like we had before when we were merging the two files. Except what we're going to be doing here is updating information if necessary once we find the correct master record file. So I like looking at the pseudocode better, so we have the same startup as we had with the other example. We open our three files, we're going to read from the master file, we're going to read a record from the transaction file, and then we're going to check and see if we're at the end of file. So what read master does is reads one record from the master file, and if it's an end of file, we're going to say that the master customer number is at the end number. Same thing for transaction. Now, if they're both at the end number, we're going to set our done flag. Both are at end is set to yes. Now, our processing is going to be a little involved, but basically, if the transaction customer number we just read from the transaction file is equal to the master, we're going to add it to the total and write a record out. And then we're going to read the next master record and the next transaction record, check for end of file, rinse and repeat. If it's not equal, then we have to decide if there is no master record, in which we're going to put out a message, or if there is, If the transaction number is greater than the master record number, then we need to read the next master record. If we don't find a match, then we got to read the transaction record. So that lets us process through the file, reading records from both files as necessary. We're not going to do any code like this. We're not going to get this involved. I just want you to understand this concept from the big picture, not the detail. So here's an example of the master file, customer number, master customer number 100. We read this record. We read the transaction number 100. So we're going to get 1000 plus 400. We're going to write for customer number 100, it's going to be 1400. Okay. Now we've processed 1000. We're going to read 102 from the master record, and we're going to read 105. So when we look at this, we're going to go, there is no 105 in the master record. We need to write a new record to our new file at 700. Okay, then we're going to read 103. It still doesn't match. There is no 103 in the transaction record, so we can just write this to the output file. And then finally we get to 105 and 105, so 75 plus 700, it's going to write 105, 775, read the next transaction. So it doesn't match. We write that out to the new file. It doesn't match 109, so we know there is no 108 in the file. We write this out. Then we read 109, 1010. There is no 109 transaction. We write out 109, 4000. And then finally we have a match again. So 110, we're going to write 900 out. So you're stepping through the files, adding the transactions to the master if necessary. Otherwise, you're writing a new master record for the missing number. And then finally, when you're done, you close everything. Random file access allows you to not have to read the file in order. You can jump directly to record 25 or record 2500 or record number 5 million. This is more like a database application. So with batch processing, we're going through the file in order using sequential files. A real-time application like I log in to check your registration, it's going to go read some random records from the database based on your G number and the current semester. So that would be a real-time application or an interactive program that's using a random file or a database. So random file access, you can access the files in any order. Instant access files, it takes a little while to get to them, but very little time. You do not have to read through megabytes of data. If you're trying to get to record 1 million, you do not have to read records 1 through 999,999. You can jump straight to record number 1 million. So that's also known as a direct access file, and that's beyond the scope of what we're going to do in our coding examples. So you can see here, to get to the 5th record with a sequential file, we have to read the first 4. To get to the 5th record with a random file, we can jump directly to record number 5. So that actually brings us to the end of this chapter. And I think you know how stuff is organized on a computer. Just remember that that extension is there even though you don't always see it. They're stored in a hierarchy of folders. To use a data file, you must declare a file handle, open it, open the file, read from the file, or write to the file and close the file. Sequential files are in order. Control breaks are when we're trying to get subtotals like by department or by state. Merging files is taking the same data but in 2 different files, the same format of data, and merging it into one file. Okay? If we have a master file, it holds the permanent data. We are going to update that file from a transaction file. So the master file holds the relatively permanent data and the transaction files update it. And then real-time applications are going to require a random file or a database, also known as instant access files. And that brings us to the end of the Chapter 7 lecture.